Students, now we will see the unit number 3 in technical drawing. Unit number 3, there is only one topic. It is known as projections of solids. In projections of solids, we have simple cases as well as special cases. We will see the introduction now, and we will proceed to problems in both simple as well as in special cases. We will see in further videos. So in unit 3, this is the content we have in our syllabus. A projection of simple solids like prisms, pyramids, cylinder, cone, when the axis is inclined to one of the principal planes and parallel to other by rotating object method. So here also a rotating object method. So auxiliary plane method is not at all required. Building blocks. So these are the building blocks. These simple solids are building blocks with which we can build any solid or any shape, in any component with any shape we can build. So that is the main purpose of the simple solids. These are called as building blocks, and components have different shapes. Any component will be formed of a single solid or combination of solids of different shapes. So we can combine and we can build a shape, whatever shape we need. The most common geometrical solids are prisms, cylinders, cones, spheres, and pyramids. So drawing of components like machine parts require a thorough knowledge of projection of basic solids. So these basic solids is very much required to build any type of solid which is in existence. So projections of solid, a solid has 3 dimensions. It is length, breadth, and thickness. At least 2 orthographic views are necessary to represent a solid. So here, so far we have seen the top view as well as the front view. So they are orthographic views. So minimum number of views required to describe a solid or component are two views. So they are normally front view and top view. In a few cases where the description can't be defined, or we cannot get the clear picture of component, there we may require the side view also. Sometimes additional views projected on auxiliary planes, that is side view, side plane, picture plane, become necessary to make the complete description of a solid. So the types of solids, actually there are two types, polyhedra and solids of revolution. And polyhedra are of these types. A polyhedron is defined as a solid bounded by planes called faces. So it is composed of a number of faces. When all faces are equal and regular, the polyhedron is said to be regular. So normally we are dealing with regular solids, and there are different polyhedra. There are 7 in particular. So tetrahedron, cube or hexahedron, octahedron, dodecahedron, icosahedron, prism, pyramid. So these are the 7 regular polyhedra we see in engineering graphics. And for our syllabus we may not see all this: octahedron, dodecahedron, icosahedron. These are we may not see them. But we see prism, pyramid, cube or hexahedron, tetrahedron. So these are polyhedrons we are going to see here. So this is tetrahedron. It has 4 equal faces, each an equilateral triangle. So 4 equal faces. So each face is an equilateral triangle. So this is, if you open this, if you open it, right, we will get this shape, right? So each, there are 4 faces. If we combine, or if we fold, we will get a tetrahedron. So here it has 6 faces, cube, that is cube, and it is composed of 6 square faces. And if we open up this shape, we get, so the 4 lateral faces and 2 bases. And octahedron, it has eight equilateral triangles as faces, and this is, if we open up, we get this shape. And dodecahedron, it has 12 equal and regular pentagons as faces, so regular pentagons. And if we open up this shape, we get for dodecahedron. And for icosahedron, it is 20 faces, all equilateral triangles, so it is composed of equilateral triangles again, like a tetrahedron. If we open up, all 20 faces can be seen like this. And prism, this is a polyhedron having two equal and similar faces called its ends or bases parallel to each other and joined by other faces, which are parallelograms. So it is composed of parallelograms, and the imaginary line joining the centers of the bases is called the axis. So this axis line is obviously will pass through the center of gravity of that particular prism or solid. A right and regular prism has its axis perpendicular to the bases. So normally we see here right prisms only, right and regular prism only. All the faces are equal triangles. So triangular prism, this is triangular prism. The base has three sides, right? The base has three sides. So this is one side, second side, and the third side. So each base will have three sides. So vertices, that is corner points, we have 6, and edges 9, and faces 5. So here rectangular prism, this is the base has four sides, and vertices are 8, edges are 12, and faces are 6. And the pentagon prism, this is pentagon, and it has 5 sides, pentagonal prism. So pentagon, number of sides, based on number of sides we have at the base. So with that name we used to call that solid. Suppose if the base shape is pentagon, then it is called as pentagonal prism. If base shape is hexagon, then that solid is known as hexagonal prism. So likewise we name the solids. So vertices are 10, edges are 15, faces are 7 here. And in case of hexagonal prism, it is base sides are 6, vertices 12, edges 18, and faces are 8. And we have octagonal prism. Octagon is the shape which has 8 sides, and vertices are 16, and edges are 24, faces are 10. Pyramid, this is a polyhedron having a plane figure as a base and a number of triangular faces meeting at a point called the vertex or apex. So it has apex or vertex, and the imaginary line joining the apex with the centers of the base is its axis. So it is an imaginary line, so that connects the center of the base as well as its vertex through the center of gravity. A right and regular pyramid has its axis perpendicular to the base, which is regular plane figure. Its faces are all equal and isosceles triangles. So that is the very important isosceles triangles. It is composed of isosceles triangles. Then it is a triangular pyramid. So triangular pyramid, the base has 3 sides, vertices, edges are 4, edges are 6, and slant faces are 3. And rectangular pyramid, it has 4 sides, right? And it has 5 vertices, 8 edges, and there are 4 slant faces. Pentagonal pyramid, the base has 5 sides, and here vertices are 6, edges are 10, and the slant faces are 5. Hexagonal pyramid, apex, it has all pyramids will have apex, and the base sides are 6, vertices are 7, edges are 12, and slant faces are 6. Features of a solid. So this is the axis. So this passes through center of the bases, obviously through center of gravity also. So these are known as bases, and the side faces are known as lateral faces. It is invisible edge. Invisible edges should be drawn with the dotted lines like this, and these should be drawn with very fine dotted lines. You should take utmost care drawing this dotted lines, and these are the base edges, and these are the lateral edges. These are lateral edges, and these are lateral faces. Lateral face here is a rectangle, and this is the sleeping solid. Axis passes through the center of bases, and these are the faces, right? And these are the invisible edges, dotted lines. This is the corners, and we have for pyramid you have apex, and you have axis. This is slant face. Slant face is obviously the isosceles triangle, and this is base edge, and you have invisible edges here too. So invisible edges here we are going to represent with the dotted lines. Solids of revolution, so here these are cylinder, cone and sphere. So a right circular cylinder is a solid generated by the revolution of a rectangle. So you are revolving the rectangle through 360 degrees. If you revolve for 360 degrees, you will get a solid known as a cylinder. So that's how the cylinder is generated, and one of its sides remains fixed. So it has two equal circular bases. The line joining the centers of the bases is the axis. It is perpendicular to the bases. And cylinder, this is the cylinder. It is solid of revolution, and you have these are known as vertical generators. So these are these are imaginary lines only, these generators. So you should you can divide this true shape. True shape is obviously the circle. So this can be divided into 8 generators or 12 generators. So cone, a right circular cone is a solid generated by the revolution of right angle triangle. So right angle triangle is revolved through 360 degrees about its axis. Then the solid obtained is known as cone. So it has one circular base. Its axis joins the apex and the center of the base to which it is perpendicular. Straight lines drawn from the apex to the circumference of the base circle are equal and are called generators of the cone. The length of the generator is the slant height of the cone. So oblique cylinders and cones have their axis inclined to their bases, and these are not required for our syllabus. We are not going to discuss any oblique cylinder or cone. And this is a cone. It has apex, right? It has a slant generator. So these are again imaginary generators. And a sphere is a solid generated by the revolution of semicircle about its diameter as the axis. So it is also a solid of revolution. The midpoint of the diameter is the center of the sphere. All points on the surface of the sphere are at equidistance from its center. And this is the sphere. So obviously sphere is not required for your syllabus. So sphere, whatever view you see the sphere, whatever may be the view, it will be a circle only, circular view. Frustum, when a cylinder, when a pyramid or cone is cut by a plane parallel to its base, or we can say parallel to the HP, horizontal plane, thus removing the top portion, the remaining portion is called the frustum. So frustum is like this. So obviously we have seen the frustum of cone while describing the frustum, first angle projection symbol, right? So that is also one of the frustums, frustum of cone. So this is the frustum of pyramid, and this is the frustum of cone. So this is frustum. And truncated solids is when the solid is cut by a plane inclined to the base, it is said to be truncated. So in our syllabus, mostly right and regular solids are prescribed, so we are not going to deal any the oblique solids. Hence, when a solid is named without any qualification, it should be understood as being right and regular only. So we are going to deal with right and regular solids. So this is the truncated solid, and now the truncated solid, you can see the ellipse, right? So you are cutting this cone inclined to HP. So here cylinder is cut inclined to HP, so it is a truncated solid. So it is the prism, truncated prism. Projections of solids positions. So again, there are 6 positions, like we defined for earlier cases, like lines and planes, whereas here it is very similar to line positions only. So that line is becoming axis line here. So solid axis perpendicular to the HP and parallel to VP, solid axis perpendicular to perpendicular to VP and parallel to HP, solid axis parallel to both HP and VP, solid axis inclined to VP and parallel to HP, and solid axis inclined to HP and parallel to VP, and sixth case, solid axis inclined to both HP and VP. So in our syllabus we are going to see up to fifth case. The solid axis inclined to HP and VP is not required for our syllabus. So this is the positions of solids with respect to, we are defining these positions with relevant to the axis position. So that is the introduction about the solids. We will see the problems in next coming video. We will see the basic problems, and then we will move to special cases. We stop here.